Hello everyone. Welcome to our channel, OnlyPhysics JEE Grad. So today we are going to discuss JEE Advanced PYQs from the chapter Work, Power, Energy. So today's topic will be work done by constant force and variable force. There will be 8 questions. And the second topic will be kinetic energy, potential energy, right? Conservation of energy, work energy theorem, right? These topics will have 21 questions, but we'll be discussing only 9 in this video, okay? So total will be discussing 17 question, 8 plus 9, okay? Further question will be discussed in the next video. Now, one more thing I want to uh, tell you that all these chapters will be according to the playlist. Okay, so I've just updated the playlist. Now, this playlist will be chapter wise. So we have done three videos on kinematics, right? We have done 3 videos on kinematics. So all those 3 videos will be in the playlist of the kinematics itself. Okay. So let's start our discussion. So this will be our first question. Perfect. So look, the questions from work energy will be like uh, uh, on the easy side. Okay. So let's start. We have given W1, W2, and W3 represent work done in moving a particle from A to B. So we are taking a particle from A to B along the 3 different paths, 1, 2, 3, respectively, in the gravitational field of mass m. So this is a mass m. There is no other field or anything. This m will be applying a field, and hence we are moving a particle from A to B. Okay, find the correct answer. Okay, so look, if there is only gravitational field, and we know gravitational field is yes, conservative field, right? So we will be having a conservative force, right? So if there is a conservative force on any particle, then work done by it does not depend on path. So as the particle is moving from A to B in all the 3 paths, the work done will be same. So B will be the option. Okay. So it's a quite easy question. Look, I'm telling you, the questions from work power and energy is like not so tough one. Okay, so they will be always from easy to moderate. So it's a good opportunity to attempt these questions. Okay, next we'll move on to a second question. So here we have a question. There is a force like this, x on a particle moving in xy plane. Okay, perfect. Starting from origin. So it's starting from origin. The particle is taken along the positive x-axis from to the point a comma 0. So let me make this, let's say this, we have x-axis and this is a y-axis. So I'm just showing the path of the particle. So it's starting from 0 comma 0, then it is taken to a comma 0, then it is then parallel to y-axis to the point a comma, right? So actually particle is taken on this path. Okay, so look, we do not have to worry about the path because the force itself is given, so it does not matter. We'll just use the formula and we'll get the answer. So you don't have to worry about this path. The total work done by the force. Okay, perfect. So we know work done by force was F dot ds, right? We know that, and we can write it as Fx I cap plus Fy j cap, right? Dot dx I cap plus dy j cap. So we can also write it as integral Fx dx plus Fy dy, right? So let's just write it like this. So we'll be getting Fx will be minus ky. Okay, so minus ky dx and minus, so minus you can also take common, and k also you can take it as a common. So I'll just write like this. So minus k times y dx plus x dy. Now to solve this, it's a very complicated. How we can solve? We have y into dx. So we have to either write y in terms of x, or we have to write x in terms of y. So in these type of question, always try to consider them as like some variable and solve them. So look, I can let's assume one thing. Okay, so let's say xy equals to t. Okay, so what we'll get? So if I differentiate, partial differentiate on the left and right side, we'll get x dy plus y dx will be equal to dt. So this is actually dt itself. So work done will be minus k integral dt. Look, this complicated term becomes like simple like dt. So we know it minus k into t, right? Now we can put the t back to its place. What it will be? It will be minus k x into y, right? Now look, this is the net work done. So we just need to put the limit. So it is starting from 0 comma 0 and it is going to a comma a. We don't know where it is moving from a to a comma 0, or from 0 comma a to a comma a, right? We do not need it. Just write it. We'll get minus k. This will be a square minus 0. The answer will come out to be k minus k a square. So it's an easy question again. Remember these step. Okay. So we'll be using them like many times. Okay. So let's move on to our third question. Right. So we'll try to finish as soon as possible. Okay, perfect. So this is our third question. So a uniform chain of length L, mass M, lying on a smooth table, one third of its hanging vertical downward. If G is acceleration due to gravity, the work done required to pull the. Okay, perfect. So look, these question we have done a lot of time. This is our chain. Now the third part, right? So one third is hanging. So this will be L by 3, right? So this will be 2L by 3. Okay. So we can solve these type of question like in a two ways. Now we have to do like this. So whole the wire should be on the table. So what will be the work? So we can do it like two way. So method one is using center of mass by the concept of center of mass. Concept of center of mass, right? So we'll see the center of mass will be lying on L in the length L by 6, right? So we will just have a particle here whose mass will be m by 3 because the mass will be uniformly distributed, uniform chain it is given. So this wire has a mass m by 3 and it is at a distance L by 6, right? So what will be the work done? Simply it will be m will be m by 3, G and H will be L by 6. So we'll get mgL by 80, right? The second method is we have studied that like we can generalize this situation and we can solve it. How? Let us consider from this distance, let's say we can take x downside, right? We can, from the table we can say at a distance x there will be a particle which we call it dx, right? So we can just find the work done by using integration. So this is an integration method. Okay, integration. By integration we'll have f dot dx. So this particle has been moved upside the dx, right? And force will be acting downward. So look, the work done will be, if I will be doing the work done by the gravity will be negative, and what I do, work done will be positive. So I'm moving it upward, okay, and I'm applying force on the in uh, the above, okay. So mg will be downward and f will be equal to mg. So we will have mg into dx, right? Perfect. So okay, Now look, so understand this point. This is not, I'm not taking it a dx length. So let me just write the net work done I have to do on this dx particle. Okay. So look, this dx particle I have to take at by a distance x. Okay. So what will be the work done? The work done will be this particle will have a mass dm. So we'll write dm g into x, right? So the force will be constant, right? On a dx particle. So we'll just write F into x. Okay. So dw will be df because a small force I have to apply and the work done will come out to be, so small work done will come out to be dm into g into x, right? Perfect. Now we'll integrate. So we will have work done will be integration dm. How can we write dm? It will be m by the whole length L into dx. Okay. Now the dx will come. So we will write it m by L g. X dx will be x square by 2. Okay. So what will be the length? It will be from 0 to L by 3. So 0 to L by 3. Right. So what we'll get? We'll get m by L g into L square by 2 and 9. This is 9. So we will have again the same answer mg L by 18. Right. So what I have done here is I have taken a small particle, right, of mass dm, and work done will be constant, right? If it is at a distance x, the work done will be constant. It will be simply force into x. So I'll just write like this. So this is also an easy method. You can choose any method according to you. Let's move on to our fourth question. So here we have, okay, perfect. So particle is moved from AB to BC like this, okay, shown in figure, and force will be acting. It will be alpha y I cap plus 2 alpha x j cap. Okay. Alpha is given. Alpha is what? -1. So we have to find the work done. Okay, perfect. So if I write work done as integral f dot ds, so it will be what? Integral fx dx plus fy dy. It was like that, right? Now we will get fx will be alpha y dx plus 2 alpha x dy, right? Now again the same problem we have. What? It is y dx, but it is 2x dy, right? So it is 2x dy. So how will we solve it? Okay. Now uh, you will say, sir, the path is like a complete circle, like it's a round path, right? The initial and final position is same, so work done will be 0. Why? The force is changing. We don't know if it is conservative or not, right? So we can't do like this. Now, again, we cannot consider it like we have done in previous question xy equal to t because there is a 2 here. So we have to solve it individually, okay? Now let's start. First, we'll find the work done by the when it is moving from AB path, okay? Now look, in the AB path, in the AB path, y coordinate is constant and x is changing. So dy is 0. So we can simply write fx dx, right? So it will be alpha y dx. Now for AB path, y is always 1. So we can just put it like this, alpha into 1 into dx. So we will get alpha into x. And x is changing from 0 to 1 because the coordinate of a point will be 0 comma 1 and b point b will be 1 comma 1, right? So it will be from 0 to 1. So we will get simply alpha, right? So we can find all the work done like this. Just let's find BC. So for BC, x coordinate will be same. So dx will be 0. So we can just write it as fy 2 alpha and x will be 1 into dy. So we will get 2 alpha y, right? And y is changing from this point, we can write it as 1 comma 0.5. So y is changing from 1 to 0.5. So 1 to 0.5. So it will be minus, right? So this will be 2 alpha minus 0.5 and this will get cancelled. It will be minus alpha. Okay. Next, work done from C to D. Okay. So from C to D, again, the y component is not changing. So we'll just have to take this. So it will be alpha y. Y will be 0.5 into dx. So we'll get alpha into 0.5 and we will have dx. What will be dx? So dx will be x and limit. It will be from 1 to 0.5, right? So again, it will be minus. So it will be minus alpha 0.5 into 0.5. So it will be, you can write minus 0.25 alpha, right? Next, work done by dE. So again, dy is in the y direction. The change in x component dx is 0, right? So dx is 0. We're left with 2 alpha and x is 0.5 into dy. So we will have this will get cancelled. So it will be alpha into y and y will be from, so this will be 0.5 to 0, right? So 0.5 to 0. So we'll have minus 0.5 alpha. Okay. Next, work done from EF, from the path EF, right? So it will be EF is in X direction. Yes. So Y will be, there is no change in Y, so it is 0. So we'll have integration alpha. Y is what? Y is 0 on the x-axis into dx. So we will get 0. And from again F to A. F to A, it is changing, the force is changing and displacement is happening in y direction. So x, there will be no work done, dx will be 0. So we will left with 2 alpha and x is 0 on the y axis, x is 0 into dy. So we'll be having 0, right? So total work done is simply sum of all. So it will be, this will get cancelled. So we're left with minus 0.25 alpha minus 0.5 alpha. So it will be minus 0.75 and alpha was minus 1. So we will get 0.75 joule, right? Okay, so this will be a simple question. Now we have to use the path because we cannot make a differential here, right? Perfect. Let's move on to our fifth question. So these are like easy one, okay? So this is our fifth question, okay? Perfect. So it's a very interesting question. Let's, I will make, consider it as a moderate one, okay? Now we have given two triangle like this. So this is not a actual triangle. It will be like this and then this, okay? Now BC and EF is X. So this is X, this is also X. And AB and D is Y. So this is Y, this is Y, okay? A small block of mass M is released from a point A and a point, slide down, and here it will be having a speed vc. Now from here it is also released and it will have a velocity here vf. Okay, both have same coefficient of friction. Perfect. Calculate vc and vc. Okay, perfect. So let's say this is theta, but these angle will be different. So this will be theta 1, this will be theta 2. Okay, remember this. Now let's solve. So for first, work done was change in kinetic energy, right? So there will be only we have to find, right. So it will be work done by gravity will be what? Will be as mg y. Simply it will be mgy because it is going in the vertical direction. In the displacement in the vertical direction is y. Okay, minus work done by friction into this distance. So this will be x square plus y square. So friction into root x square plus y square. Okay, the one force, so work done by normal will be 0, right? So the only force exist on this block is gravitational force and friction force be changing. So initially it will be it is initially they are released from rest, right? Released from a point, so released, so this means their initial velocity was 0 and final will be half m vc square. Okay, now friction we know how much will how much it will be mu mg cos theta, right? So we can just write it as mgy minus mu mg cos theta. This will be root x square plus y square equals to half m vc square. Simple, right? So cos theta will be base, right? This is x and this is hypotenuse. So we can write mgy minus mu mg x upon under root x square plus y square to root x square plus y square is equals to half m vc square. This will get cancelled. So simply work done by the friction will depend on the horizontal displacement of the particle, right? So we can write m will get cancelled. So it will be 2 gy minus 2 mu gx, and this is vc and this will be under root, right? Okay, so look, the friction only depends on the horizontal displacement. So here it will be the same, right? Let's solve it. So here work done will be change in kinetic energy, work done. So mgy will be the same minus for first. So I can write it as a friction 1 minus friction 2 will be equals to half m vf square. So mgy. So we can write it as minus mu mg cos theta 1 into, let's say this is x1 and this is y1, this is y2, and this is x2. And just write it. Okay, this is x1. Perfect. So it will be x1. Oh, sorry, it will be root. So this distance, it will be root x1 square plus y1 square, and this distance will be root x2 square plus y2 square. So we have to write it root x1 square plus y1 square minus it will be mu mg cos theta 2. So this is work done by friction 2, right? Yeah. So I have to write it as, just let me write it as work done by friction 1 minus work done by friction 2. Okay, perfect. Cos theta 2 into distance root x2 square plus y2 square, and it will be half m vf square. So we will get, if I put cos theta 1, it will be x1 by this, and this will get cancelled, so we'll left with the x1. So we will get mgy minus mu mg x1 minus mu mg x2 equals to half m vf square. So we will get this mgy minus mu mgx equals to half m vf square. So this is the same expression as this, right? So same vf will be vc. Okay. So this is a quite interesting question. So we'll consider it as a more moderate one. Okay. So this was our fifth question. Next, move on to our sixth question. Shall we? Perfect. Okay. So this is our sixth question. We have a mass of 2 kgs being dragged with a uniform velocity. So look, and it is a horizontal rough plane. So look, the horizontal, if it is moving the horizontal on a friction, so there is a friction, there must be friction, right? So friction will be acting in this direction. So I have to apply a force in this direction. Now the velocity is constant. So why velocity is constant? Because net force must be zero. So F must be equal to friction, right? Let me write it as a small f. Okay, perfect. So coefficient of friction is also given, which is 0.2. So I can just write friction will be mu mg, m into g. 9.8 we have to take. So we will get, just let it be like this. So F, this is F, right? This is our friction. So it must be equals to F, right? Now I have to find heat generated. So yes, the formula for heat was, yes, work done. Okay, so work done. Now the work done, we can also write it as power into time, right? And power was F V into T. So what is F? F will be 0.2 into 2 into 9.8, and velocity is 2 and time will be 5 seconds. Okay, so we will get this decimal will get cancelled from this. So we will have 4 times 9.8. Now if I have to convert it to calories, this is in joule, we have to divide it by 4.2, right? So from here, it is like approximately I can find, so 40 divided by 4.2. So this, so it will be 200 or 21. So it will be 9 point something calories. Okay. So 9 point something calories will be the answer. Okay. So this is again a easy question. It's not a tough one. So remember these formulas, right? You can derive it, but if you remember them, the situation or the time consume consumption of your time will decrease. Okay. So let's move on to our seventh question. Right. So we have a pulley arrangement system. Right. This. Okay. So it's like this. Okay. This wire is connected, like this side is connected with the B and this side is connected with A. So diameter of cylinder A is more and cylinder B is 20. Okay. The working handle has an arm of 50 centimeter. So this is 50 centimeter. The direction of winding of rope A is opposite to rope B. So look, it's like this. If I apply a force here and it is rotating like this. Now look, B is rotating like this, then A will rotate in opposite direction. So situation is like this. What is a mechanical advantage? So mechanical advantage is force applied divided by the weight. Okay, so this will be the mechanical advantage. So it will be more, it should be more than one. Then only there is a mechanical advantage. Otherwise, not. It is not. Okay. So let's solve it. Now look, if A and B are rotating in opposite direction, so if B is like B is taking the wire then A must be releasing the wire. Okay, so let's say this completes one circle. So we'll say if, okay, if this handle completes one circle, that implies A and B completes one circle, completes one circle. Okay, perfect. Now, this is the first uh, analysis I can like derive from it. The second point we can derive from it is whatever the work done will be, if it is going up, then the work done must be equal to which I'm doing. So work done by handle must be equal to work done on the weight itself, on W, right? Because there is no work done, everything is frictionless. There is no given, there is nothing discussion of friction here. So I have to consider like this. Perfect. So from these, let's solve the situation. Okay. Now we have to first find how much this weight is going upward. Okay. So for that, we have to find how much the length of the wire B is taking and A is releasing. So length of wire by B will be in one circle. Okay, so in one circle I'm talking about. So it will be 2 pi and B is 20 centimeter. So we will have 40 pi centimeter. Okay, right? And length of wire by A, it will be released. So let's just write 2 pi into, okay, so it is diameter, so I have to take 10. So it will be 20 pi. Okay, so this is 15. We have to write 15. We'll get 30 pi centimeter. So wire, uh, net wire, so net wire coiled around this arrangement. Okay, so it will be 30 pi minus 20 pi. Okay, so everything is centimeter, but still I'm mentioning the centimeter. So it will be 10 pi centimeter, right? So look, if 10 pi of the wire is uh, is coiled around this arrangement, then this side must be giving 5 pi and also this side is giving 5 pi, right? So the weight is going by a length 5 pi up direction, upward direction, right? So we can just simply write work done on W will be equal to the weight, because tension will be equals to W into 5 pi, right? So W is what? It is weight of box, right? Now work done by the F or the handle. So it will be, now look, I will be applying, so if I'm rotating this handle like this, I will be applying F in the tangential, and what will be the total distance will be, this is 50 centimeter, so total distance will be F into 2 pi, R will be 50 centimeter, right? So we will have 100 F, 100 pi F, right? Now let's find the mechanical advantage here. It will be force applied. So look, the work done are equal. So we'll write just 5 work done on W will be F into 5 pi, W into 5 pi, sorry. And the work done by the handle will be 100 pi F, right? So pi will get cancelled. We will have 20. So applied force was F and this was weight, right? This was weight. So yes, it will be 1 by 20, right? So like so what is the mechanical advantage? It is 20 times, right? So I have to apply F. So you can write it as, like, I have written it wrong here. It will be the weight of object divided by force applied. Okay. So we will have weight upon force applied will be 20, right? So look, if the weight of the object is suppose 1 Newton, okay, or let's say it's 20 Newton, then I have to apply only 1 Newton of force. This is called mechanical advantage. Okay. So it's a different term, but the concept is similar, where in the hydraulic press we have studied, right? In the mechanical properties of liquid. So it is like the same. Let's move on to our last question of this topic. Okay. So we have a wire which passes through the hole of a small bead and is bent into form of quarter of a circle. Okay. The wire is fixed vertically on the ground is shown in figure. The bead is released from near the top of the wire and it slides along the wire without friction. As the bead moves from A to B, the force applied on the wire is so by the bead. So first we'll see what will be the force applied on the bead. So we have studied this term, right? If we released an object from here, what will happen after a certain angle? It will just leave the contact, right? But in this case, the bead will not leave the contact, okay? So let's analyze these two situations. So first, this is our situation one, this is our situation two, okay? So I'm splitting it in two situations, right? So in first situation, we will see, so if it is in, it remains in the contact, then mg will be here. So here will be mg cos theta. Here will be, let me rub it. So this was our path. So it will be mg sine theta tangentially, and normal will be in this direction, right? And we have here mv square by r centrifugal force, whatever, right? So look, in the first case, normal on bead, right? Normal on bead will be radially outward, radially outward, right? In situation one. But in situation two, what will happen if it is losing the contact here, but bead is connected here? So the bead wants to go here, right? It will move like this, or it will move like this. So bead wants to go here, but as this wire will not let it go here, so this wire will apply a force in this direction, right? So this time the normal on bead will be radially, yes, radially inwards. Okay. Now, what is asking? The force it applies on wire. So it will be opposite. So in first case, it will be radially inwards, then radially outwards. Okay. Then radially outwards. Right. So which option will be radially inwards initially, radially outward? So D will be the option. Okay. So it's a moderate question, but remember the situation. Okay, so first, if I put a box on top and it is released from rest, then at some point it will be losing the contact, right? But as beads is stuck in the wire, so initially the normal on the bead will be outwards as it remains in the contact. But after it is trying to go outwards. So wire will say, I will not let you go outward. So wire will apply force on towards, yes, towards radially towards inwards, right? It will be inward, right? It is asking opposite, so I have to write radially inwards initially, then radially outwards later. Perfect. So this is a moderate question. Let's move on to our second topic, which is kinetic energy, potential energy, conservation of energy, and work energy theorem. So, total of 9 questions we'll be discussing. Let's start with our first question. Okay, perfect. So we have a block of mass 2 kgs free to move along x-axis. Okay, it is at rest from t equal to 0. So u is 0, subjected with a force like this. So Ft we have in the x direction always. Okay, now we have to find the kinetic energy. So if we can write work done by force will be change in kinetic energy. So it will be directly half mv square minus 0. So we just have to find the work done equal to half mv square. Now the force, it is acting in x direction. So we'll write here F dx will be equals to half mv square. Now the problem here is F is given in terms of t and we have to integrate with respect to x. Is it possible? No. So this approach is not right. So let's just write first force. So this is a simple straight line. So we can write y equals to mx plus c. Slope will be minus 4 by 3. So y will be minus 4 by 3 x plus y intercept is plus 4, right? So we will get simply y was f equals to minus 4 by 3 t plus 4, right? So we have this force. Now I have to find kinetic energy. So simply we have to find the velocity. So from there we can find force is m dv by dt is equals to minus 4 by 3 t plus 4, right? So just rearrange, we'll get m dv will be minus 4 by 3 t plus 4. This is dt. Let's integrate them. So we will get m v from 0 to final v because initial was 0. We'll get minus 4 by 3 t square by 2 plus 4t, right? So from 0 to 4.5 I have to put. Now m is 2, right? 2 into v will be equals to, let's put 4 by 5, so minus 4 by 3 into 4.5 square by 2 plus 4 into 4.5, another will be 0. Yes, so this will be 2 and 2 will get cancelled from all these. We will have v velocity will be, so it will be 445 into 45 divided by 100 into 3 plus it will be 9, right? So we will have 15 and this is a minus, so we'll get 9 minus, so it will be 15 into 4 600, 15 into 5 75, so 675 divided by 100, right? So we'll get v as 225 by 100. Okay, now I have to find the kinetic energy. It will be simply half m into v square, so it will be 225 divided by 100 square, right? It will get cancelled. We will have 225 into 225 divided by 100 divided by 100, right? So it will be 9 by 4. So this will be 9 by 4, right? So 81 by 16. Now 16, 5, 16 to 5, 80. So it will be 5 point something joule. So which option will be? So C is the correct, right? So it's an interesting question. Look, just follow the concept. If you're not getting it, then change your approach. Right? I've done like this. Let's move on to our second question. Okay, perfect. So we have a blob of mass m is suspended by a massless string L. Okay, the horizontal velocity v at the position A is sufficient to make it reach at B. Okay, the angle theta at which the speed of B is half of that A satisfies. So there were options which is missing. Let me just write those options for you. So first was theta will be pi by 4. Second was theta belongs to pi by 4 to pi by 2. The third was theta belongs to pi by 2 to 3 pi by 4. And the fourth option was 3 pi by 4 to pi. So these are option. Okay, so 3 pi 4 will be 135, right? So it is 135. Okay, perfect. Now, okay, so look, the one thing should be clear here is that this particle must be moving in a circular path. Okay, so to just reach at point B while moving in a circular path, the velocity must be given root 5 GL, right? Okay, perfect. So we can just use conservation of energy here. Now, let's say this is a point B. So height, it will be going up will be at this length will be L minus L cos theta, right? So by a length L minus L cos theta, it is going in the upward direction. So let's say this is A point and this is particle B having a velocity V, right? Here it has a velocity U. It will be root 5G. Okay. Now let's say the potential energy U is 0. Okay. And now the potential energy here will be mg L minus L cos theta, right? So we have work done equals to change in kinetic energy. It will be half m v square minus half m u square. It will be 5 g L, right? Which will be equals to work done. This is final minus initial, so it will be minus mg L minus L cos theta. So we have m will get cancelled. G will also, okay, so let's say it's just G. So will be 2G L minus L cos theta will be equals to half mv square minus, so half will get cancelled, m was not also there. So it's just 2, it will be 5G, right? So we're left with 5GL minus 2GL minus 2GL cos theta will be equals to V square, right? So we will get 3GL minus 2GL cos theta equals to V square. So this is our final equation. Now in question it is given at point B, we have to find the theta such that at any point B, the speed of bob is half of that A. So at A it was speed root 5GL, so it will be half of that. So we will get 3GL minus 2GL cos theta will be equals to root 5GL by 2 whole square. So we're left with 3GL minus 2GL cos theta will be equals to 5GL by 4. Yes. So if we rearrange, we'll get, so GL will get cancelled, right? So it will be 3 minus 5 by 4 equals to 2 cos theta. So this will be 12 minus 5, 7 divided by 8 cos theta. Now if you solve, this theta will come between 3 pi by 4 to pi. Okay, so D will be our option. Right? So this question is again an easy question. But here you must understand that at the bottom, to move in a circular path and it will reach at just point at B, we need speed root 5 GL. Okay, next, let's move on to our third question. Okay, perfect. So ideal spring we have, it is attached to a mass K lower, and the mass is released initially unsteady the maximum extension. So we know this is a very easy question. This was mg by k. Here this position is equilibrium, but it will further go mg by k, and here it will come at rest. So here this is v0, right? This is an extreme position, so the maximum elongation will be 2 mg by k. So this is a pretty easy question, we have studied it, right? Let's move on to our fourth question. Okay, so here we have a particle is constrained to move in x-axis, force in same direction in x. This is given. So we have force minus kx plus ax cube, right? Right? This is okay. So we have to find u. So we know F equals to minus del u by del x, right? So we can just write it here as b minus du by dx equals to minus kx plus ax cube. So we will get du integration minus, this is 0 to u, we can put it. So we do not even have to limit, just we'll do indefinite integration here. It's minus kx plus ax k cube. This is dx, and we have integration. This is minus kx. Okay, so we'll get minus kx square by 2 plus ax 4 by 4, and this will be minus u. So we will have u as q x square by 2 minus ax to the power 4 by 4, right? Now we have to make the graph. We have to understand this. So we know at x equal to 0, u will be 0. So this option is wrong, right? Now, perfect. I have to find, okay, so we know, let's find the point where u is 0, okay? At x equal to 0, or we can just find it by putting it to 0. So we'll get x square common. So it will be k by 2 minus a x square by 2, 4. So we know x is 0 at u is 0. So we'll get another point will be x square a by 4 will be k by 2. So this is 2. We'll get x as 2k by a the root. So this is our second point where u is 0, right? So B option is wrong because there must be another point. So this or this. Now, one thing we also know that if the if slope of the slope du by dx is 0, that means force is 0, right? So let's find that. So if I put force 0, so we will get minus, so x we can take common, minus k plus ax square. So we will get either x equals to 0 or x equals to root k by a. So look, this point is root 2k by a, where u is 0, and here it's this point is before this. Here f is 0 means slope of ux is 0, right? So look, if this is our point, right? And here the slope is 0 and this is our root 2k by, so this is 0. So both are matching. Now we just have to find after x root 2k by a, what will happen? Is it decreasing or it will be increasing? So if I put, let's just put x to infinity. So if I put x infinity, this will be more. So x infinity, u will be minus of infinity, right? So what option, which option will it be? So it will be simply this option. It will go to minus infinity. So this is wrong. It is going to plus infinity, right? And it is bending like this. So this graph is wrong, absolutely. Okay. Now you can also find it like at this point, you can find u. So if you put u here, it must be positive, right? So there are many methods to solve. This is a pretty easy question, graphical question. There is not much physics in this, right? Let's move on to our fifth question. Perfect. This is our fifth question. Okay. Now, a spring force of K is cut into two pieces. One piece is double the length of other. Okay. So if we have a spring constant K of length L, it has cut in such that if this is X, then this will be 2X. So X plus 2X will be L. So X will be L by 3. So this will be L by 3 and this will be 2L by 3. Perfect. Long piece will have a constant. So we know spring constant is inversely proportional to length. So we can just write K equal to C by L. Okay. Now let's say this is K2, this is K1. So K2 will be C by 2L by 3, right? Now we have to find the spring constant of the long piece, which is K2. So just divide them. We will get K by K2. CL will get cancelled. So this will be 3, right? So this will be 3 will come here and 2 will be. So it will be 2 by 3, right? So this is denominator's denominator, and this will be here 3 and 2 will come here, right? So simple, we'll get K2 as 3K by 2. Okay, cross multiply just what to do. So K2 will be 3 by 2K, right? And we know the spring will the spring constant will increase if the length is decreased, right? So it will get more stiff, right? Let's move on to, so it's a simple question. Let's move on to our sixth question. Okay, perfect. Now, a stone is tied to a string of length L is whirled around in a vertical circle. Again, the vertical circle question. So, at the other end is at center, okay. At a certain instant of time, the stone is at its lowest position, and here the speed is u. Perfect. The magnitude of change in its speed or velocity when it reaches a point where the spring is horizontal, the string is horizontal. So here, let's say this has v and this has v naught. Perfect. Okay, so you we have to take. So let's use energy conservation. So it is going by a length L. Okay, so we will have simply mgl will be equals to half m u square minus half m v square, right? So what we'll get, m will get cancelled and we get v square as u square minus 2gl. So we will get v as root u square minus 2gl. And from this, you will take this option, but this is wrong. Why? Study this question again. Magnitude of change in its velocity it is asking, right? So this is our final, and we have this. So initial velocity will be u I cap, and final velocity will be j cap. So this will be root u square minus 2gl j cap. So change in velocity will be v final minus v initial, right? So it will be root u square minus 2gl I cap j cap minus u I cap. And now we have to find the magnitude of this change in velocity. Okay, so be careful while solving these type of question. They can mess with your mind. So it will be under root square of this. So it will be u square minus 2gl plus u square. So it will be, sorry, u2 u square minus gl. Yes. So this is not the answer. This will be the answer. Be careful while solving these type of questions. They're easy but tricky, right? Next, let's move on to seventh question. Okay. So it's an easy question, I think, right? We have two masses, different mass have equal kinetic energy. So kinetic energy of one, and we have to find the magnitudes of momenta. So it's easy. It will be p square by 2m1, and k2 will be p2 square by 2m2. So both are equal. So we'll have p1 square by 2m1 will be equal to p2 square by 2m2. So we will get p1 square by p2 square will be m1 by m2. So we will have m1 as 1 divided by 4. So we will get p1 by p2 is 1 by 2, right? So C option will be there. So pretty easy question. Let's move on to our eighth question. Okay. So again, a force and u versus x. So force is kx, which is minus du by dx. So similarly, we can find minus du integration will be kx dx. So we will get minus us kx square by 2. Yes. So u will be kx square by 2 with the negative sign, right? So it's a equation of parabola which is in downward. So B will be the correct option, right? Perfect. And potential energy at x equal to 0, it is given u 0. So we can also limit. We can put also limits here. U at x equals to 0, u is 0, and at some x equal x potential energy is 0. So this is an easy question, right? Extremely easy. Perfect, right? So we have done 8 question. Are we left with any question? Let me check it again. So first, this was second, this was third, this was fourth, this was fifth, the sixth, seventh, and eighth. So I think we have discussed all the question here. If we have left with any question, we'll discuss in the next, right? So there are total. Okay, so right, this question is from work power energy. So, no, it's a normal question. It's just a force question, right? Okay, perfect. So further question we'll discuss in our next video. Let's finish this today's session, shall we? Okay, bye bye everyone.